Good morning, everyone. Today we're going to discuss the assumptions of, I should have placed here, assumptions of MLR, which is multiple linear regression. So let's start with that. Before we discuss the mathematical or the model for MLR, let's have a discussion of the nature of multiple linear regression. So multiple linear regression, I'm sure you have met this topic in your prior subjects. So this is more of a not really a review because we'll dig deeper. I'm sure your other subjects in MLR were not really that deep. And besides, we're going to make use of R as our software. Okay. Pasensya na class, medyo may cold ako. So what's MLR? When I say MLR, that's multiple linear regression. It's a statistical technique, and we're trying to establish or determine the relationship, our association between a dependent variable and two or more independent variables. Now notice I said two or more, because if there's only one independent variable, only one predictor, then we call it a simple linear regression. So if you're using two or more regressors or predictors, then we call it MLR, multiple linear regression. Okay, so it's an extension of the concept of simple linear regression. As I said a while ago, simple linear regression makes use only of one predictor as compared to multiple linear regression that makes use of several, more than one predictors. Okay, the method used in coming up with a linear regression is what we call the OLS, the ordinary least squares. Okay, we're going to discuss this in greater detail as we go along. Now, the mathematical model, okay, let me share this with you. Okay, so you can see that I'm using LaTeX here. Let me just show the formula. So you have your dependent variable y, okay, and it's equal to a certain constant called the intercept plus your parameters beta 1, beta 2, beta 3, okay, multiplied by your x1 I, this is your first predictor, second predictor, up to p predictors. So you have this model where you have p predictors plus a certain error term, okay, plus a certain error term. And it defines to us that your y sub I is your dependent variable, okay, for observation I. X1, X2, up to XP are your independent variables. These are your predictors for sumobra yata sa line ko, no? Okay. These are your predictors for observation I. Let me just, sige, ipunta ka lang to class sa kabilang ano, ha? Predictors, okay, close ko, and then text. Let me just put a space there. Okay, kasi ano nangyari? Are the predictors, sorry. Okay, text. There. Okay. Okay, now how am I writing this? I'm using LaTeX. Okay. For those of you who have not met the term LaTeX class, itong equation na to is actually done in LaTeX format. So this is very useful, especially if you're rendering this as a PDF file. So notice it starts with $, okay, and ends with $, so that we can print what's inside this this formula. Okay, I'm not going to discuss so much the the technicalities of the LaTeX formula. But so just for a simple discussion, you can see here y underscore I. The underscore here will print this as as a subscript there. Kita nyo, no, y underscore I. And notice class, yung y natin dito is in itals. Naka-itals siya. No? So you have here slash beta. This one class, slash beta will give you the Greek character. Slash beta and then underscore 0. So we know that this should be beta, the Greek character, and then subscript niya 0. So if you take a look at this class, ayun siya, no? Here. Ganun din dito. How do you write this? Slash beta underscore 1. Okay, and then x underscore open and close parenthesis 1i. Okay, so that's written this way here, no? Slash beta underscore 1, and then slash underscore 1i. Now we are discussing this not so much in detail because in your second case you'll have to write your equations this way. Okay, dapat ganito yung kakalabasan ng mga equations natin. Hindi yung naka-type set lang na ordinary. Okay? You can see here, class, underscore C dots, di ba? That's combination of dots there. Center dots actually. And then plus beta P, X sub Pi plus epsilon. Epsilon sub I, how did I write epsilon sub I? Okay, here. Slash epsilon, kasi Greek character to, no? And then underscore I. Okay, so for purposes of you learning also this one, Control C, I'm going to share this in the chat box and kindly copy that in your R Markdown file. Okay, copy nyo. Tapos, okay, dun sa $, mag-control enter kayo there para ma-print tong ano, what this stands for. Okay, so kindly chat please if you were able to get it. Get the LaTeX format and then also the printout. Okay, so please start learning that also, class, because the next case will be all about multiple linear regression, and definitely you'll be required to write formulas, write equations. Okay, so as I said, y here is your dependent variable and your x's are your independent variables or your predictors. And there are several of them, x1, x2, up to xp. Okay, so there are p predictors in this case, and these are your independent variables. Okay, your epsilon sub, your beta null here, this one is your intercept term. This is your constant. And your beta 1, beta 2, up to beta p are your regression coefficients. Okay, and then epsilon sub I is your error term or residual for observation I. And then later on we'll discuss that your epsilon sub I should be IID. Okay, IID, this means IID normally distributed, and then with a mean 0, and then a constant variance. Okay, you have to learn, class, the terminology in multiple linear regression, in regression. Okay? Although hindi naman tayo BS Math, pero importante sa atin to, class, no? Kasi there will be many references that you might be reading and looking into, or journal articles, and sometimes they mention this. So it's imperative for us to know what this symbolism stand for. So this is IID, no? Independently and ano isang I, distributed yung isa. Sorry, I forgot the other I. But it's normally distributed with mean 0 and standard deviation equal to a constant standard deviation. Okay. So what's the use of multiple linear regression as regards finance, marami class, no? It can be used to model, predict stock prices based on economic indicators. So there are journals where you try to predict, you predict the returns of it's more of predict stock prices or returns. It can be both, no? You can be predicting stock prices or you can be predicting returns. And you're using several independent variables or several predictors like GDP growth, interest rate, money supply, etc. Okay, so this is just one example of the so many applications of multiple linear regression. Okay, you can also use multiple regression to estimate credit risk. Okay, and again, there will be independent variables that we're going to use in order to explain or determine a relationship between your independent variables and your dependent variable. Not only in finance, this can also be used in strategic finance, okay? Where in strategic finance, take a look at budget allocations and you take a look at several factors that affect budget. So finance is not only, does not only focus on finance-related aspects. Pag finance class, later on, if you go up the corporate ladder, lahat ng functions, sakop ng finance. Lahat ng functions may sakop, may interest ang finance, whether it be HR, whether it be marketing or operations, okay, or IT, finance has an important role in that. Okay, so that's number 3, looking at the impact of any strategy, okay, any intervention done by the company, whether it be marketing or operational or people management, etc., on certain, let's say, budgets or profitability, okay? All right, and other forms class, other uses. This is just a, I'm just, this is not even scratching the surface, okay? Now, this equation class, ito, no? This is our model. Y sub I is equal to beta null plus beta 1 x sub 1I. Okay, the whole rationale for doing multiple linear regression is to establish relationships between your independent variable x, your x's, and your dependent variable y. Okay, so the goal is to create a model by defining what are your parameters, what's your beta null, beta 1, beta 2, beta 3, etc. So when you're able to define what these parameters are, then you have established a model relating your dependent variable to your independent variable. Okay, of course, there are steps in order to do that. And after we have established this, we have to diagnose our model. So it's not enough that you're able to solve for beta null, beta 1, beta 2, beta p, etc. It's not enough that you're able to solve for these parameters. What's important is that we have to diagnose the model. We have to check the model for its validity, because there are certain assumptions that we make when we create this model. And the assumptions have to be validated, whether they are met or they are violated. So we'll take a look at that in greater detail. Now, for most of you who just took your maybe DSI LITIC, it's a subject offered by DSI. Maybe you did multiple linear regression, but I'm not so sure if you did diagnostics in greater detail. And besides, I'm not so sure if you did multiple linear regression using R. Most probably it was Excel. Okay, so your system, okay, your data, for example, class, we take a look at the, let's open wage data. Okay, could you kindly open wage data? Buksan natin, class. Okay, let me open that. Okay, paki-open class yung wage data. Then let me show you how multiple linear regression is done, okay, by way of explaining the formula or the concept behind the solving for your parameters, your betas. Okay, isa na siya. I think. Okay, ito. All right. So we have this class. We have our data. It consists of 527 observations. Okay. And then we have our variables: education, experience, tenure, race, gender, civil status, number of dependents, and hourly wage. Okay. The first objective, the first lesson that we're going to do is to create a model where we would like to establish the relationship between your dependent variable, which is hourly wage, okay, and education, experience, tenure, etc. We'd like to know if we can predict hourly wage given education. So does education have an impact on the hourly wage of this employee? So this was taken this data is from US 1970s pa to, no? So we'd like to know whether these variables, these predictors, have an association or can be used to predict hourly wage. Okay, so this is this is for example y sub 1. Okay, this is your first observation. This is your second observation. This is your third observation, etc. Okay, so we're going to use this x's, x1, x2, x3, x4, x5, x6, x7, and this one y. So in multiple linear regression, there is one dependent variable and several independent variables. Now notice that our dependent variable is quantitative in nature. Okay, for multiple linear regression, the dependent variable should be numeric. Okay, the independent variables can take the form, can be of any type. So you notice here, education is numeric, experience, tenure, all of them are numeric. And then we have here race, gender, civil status that are categorical or character. And the number of dependents is also numeric. So you have some independent variables that are character and some independent variables which are numeric. The dependent variable should be numeric. Take note, it's not integer, okay? And take note, it's not character. So the multiple linear regression will only work if your dependent variable is quantitative or numeric, okay? And it's a special type of numeric. It's not integer. Neither is it a factor class. Because, for example, can we predict if we're using this as our dependent variable? So you have single, married, single, married. Can we use multiple linear regression here, class? What if we convert this into single is 0 and married is 1? So that becomes also a number, class. Okay? The answer to that question is no, we cannot use multiple linear regression if civil status is the dependent variable. Okay, why? Even if we convert it into a 0 and a 1, okay, 0 for single, married is 1. Yes, we cannot choose multiple linear regression. Why? Because if this was your dependent variable, then it becomes not a quantitative, okay, not a numeric dependent variable. It has become an integer that can be classified as a factor. When you say factor, it's technically a categorical variable, which we use for classifications. Okay, so in that case, class, MLR will not hold for this. So what's the method when you're modeling this? If you're trying to predict if it's possible, class, no? If you're trying to predict whether it's single or the respondent is single or married using the other factors, then we call it binary logistic regression. Okay, so later on we'll discuss that in a few sessions time. We'll be doing binary logistic regression, and they are for those with dependent variables that are factors. By factors I mean classifiers. Okay, if there are more than 2 classifiers, then you cannot choose binary. Okay, you'll have to use, so the first one is binary logistic regression. This is when your dependent variable okay, is a factor with two levels. If it's a factor with several levels, then you will not be able to use binary. You'll be using multinomial logistic regression. For this course, we're only going to deal with, of course, MLR, multiple linear regression, as I said, where your dependent variable is quantitative. Okay. We're also going to discuss binary logistic regression, but we're not going to discuss multinomial. Multinomial is akin, quite similar to binary. So if you understand binary logistic regression, it will be very easy to understand multinomial. Kasi parang, ano lang siya, binary logistic na dinoble lang. Okay? All right. Now, so what's the goal of linear regression, multiple linear regression? So the goal of multiple linear regression is for us to generate an equation. For example, y sub I. Okay, y sub I is equal to, okay, my mouse is y sub I, okay, is equal to, so this is our dependent variable. So this is something to do with, in fact, we can replace it by hourly wage. Okay. Hourly wage sub I is equal to, you have a certain constant, okay, plus B1 times education, plus B2 times experience, plus B3 times tenure, B4 times race, B5 times gender, B6 times civil status, and B7 times number of dependents. So that's our goal class in order to generate this one, this equation. Okay. So if we were using the wage data set, this will be our hourly wage. Our beta null will be our intercept. This will be our constant. Beta 1 times education, beta 2 times number of dependents, etc., etc. So we have 7 predictors. Okay. Now, how do you solve for this? How do you solve for beta null, beta 1, beta 2, beta 3, etc.? Okay, mathematically, this can be solved using matrix algebra. So let me show this to you, class, this one. Okay, that Excel file, class, that CSV file, this one, where you have 500 plus observations, 526 observations, you can actually replace that. I hope you're already done with FinMath. You can replace this as a matrix, as a matrix formulation. And the matrix formulation will look like this. Your Y, which is your vector of responses, in our case, this is the vector of your hourly wage, is equal to X. Vector because it's only one, okay? Y is a vector because you only have one dependent variable. X is the matrix. Matrix because there are several independent variables, okay? Let me just annotate this. Okay, so this is a vector, okay, because you only have one. Okay. So we know that this is y sub 1, y sub 2, y sub 3, okay, until y 520, I think it's 526. Okay, so all the y's here, class, all the y's here, all the values we find in our CSV file, the hourly wage will be your vector of dependent variable. And then your X, class. What will be your X? Our X will be, this is our matrix of your education, diba? X1 hanggang X7 yun, diba? Up to X7, up to number of dependents. So here we have number of education, and you have your race, gender, etc., and up to number of dependents, right? Everything there, all the values there, is your X matrix. Matrix of predictors, matrix of knowns. Okay? And then you're inserting another column okay? Because you're going to include the intercept. Okay, so let me just show that. Okay, so mathematically, class, okay, mathematically, our model class will become, so this will be, draw, okay, this will be our beta null. This will be our beta 1. Okay, itong row na to, beta 1 to. Sorry. Ito yung X1 natin, class, education. X2 natin, experience. Okay. X3, X4 hanggang X7. Okay. This is your Y, di ba? This is your Y vector. These are now yung from 11 na to hanggang pababa, class. Okay. Plus another one, magi-insert tayo dito kasi may intercept tayong sinusolve yung beta null. Okay. So what will happen is that we're going to introduce, okay, let me do that. Oops, sorry. Okay, so ano. Delete ko lang to, ha. Okay. And then insert ako dito. Okay. What will happen, class, is that there will be another column here, another vector. This will contain mga 1. Sorry, 1 lahat yan. 1. I'm showing you how this is computed, class, although siguro papakita din natin yung matrix matrix formulation. Okay. So what's this, class? This whole one. This will be your vector of it. This is your X vector. Okay, this one. Yung buong to. Hanggang number of dependents, hanggang baba. Class. That's your vector of predictors. Of course, class, may gagawin si R dito, no? Kasi character to eh. Hindi naman pwedeng isolve to using matrix algebra if there are categorical variables. This will be converted, class. Iko-convert siya into numerical. Okay? But this will now be this is your beta null column. This is your intercept. Beta 1, beta 2, etc. hanggang beta 7. Okay? So your X matrix, class, your X matrix is actually ilan lahat to 526, no? Your X matrix is ilang rows? 526 observations. Hindi kasama yung name ng variable by 7. Rows by columns. So this is the size of your X matrix, class. Okay? I hope your show of hands, please, class, kung nag-FINAMAT ba kayo? Tapos na kayo nag-FINAMAT where you discussed linear algebra. Good. Okay, you're supposed to discuss that there, class. So nag-matrix operations din kayo, no? Yes, class? Good, good. Okay, so good. All right. So 526. So that's your matrix of predictors. And then tingnan ulit natin yung formula natin, class. Let me escape this one. Okay, going back here sa R natin. Okay. You can see here, class, this is your matrix of responses or your dependent variable. Ang size niya, number of rows is 526. 526 rows by 1. 1 column lang siya. No? Ito namang X class, kanina, we were able to show that this is 526 rows of observations by 7. Okay? 7 is the number of columns. Okay. Tapos yung beta natin, class, ano yung beta column natin? Our beta column will be beta 0, beta 1, beta 2, hanggang beta 7. Okay? So this is also a vector of coefficients. Yun. So ganito itsura niya, class. So the size of beta will be, ano size ng beta? 7 by 1. It will be 7 rows by 1 column. Okay? And then we know, class, from matrix algebra that you can only multiply these two matrices if they're conformable. Okay, what do you mean by conformable? This is row by column, diba? The column of the first matrix is equal to the row of the second matrix. So 7 by 7, conformable siya. Okay? Tama, equivalent siya. So multiplicable tong dalawang matrix na to. And then the resulting matrix is 526 by 1, which is the same as 526 by 1 here. Okay? And of course, the epsilon, in order for it to be added, okay, ano ba yung errors natin? The error term is a vector of your residuals. So bawat observation merong error. Kasi hindi naman, usually hindi naman pareho yung actual value at saka yung model value. So this is also, ilang rows to? 526 by ilang column? 1 lang din. Okay, that's why you can add this one, class. Itong x times b plus epsilon. These are, you can add this. Okay, and then they're the same as the column, as the size of the vector 526 by 1. Okay, so class, this is actually how to solve your b. Kasi from this matrix multiplication, you can now manipulate this so that on the left-hand side will be your beta. Okay, ganun ang nangyayari dito, class. In order to generate this multiple linear regression model, where the objective is to solve for your betas, then we make use of this matrix multiplication and then solve for your beta. Okay, solve for your beta. Okay, let me pause for a while and ask class if so far clear ba tayo dito sa clear drawings, and then close ko lang to. And then let me share with you the LaTeX para ma-print nyo rin. Okay, Control C. Tingnan nyo, class, ha, i-aralan nyo rin kung paano ginagawa yung LaTeX, LaTeX formula. Okay, this is very powerful as far as R is concerned. Yan siya, no? And take note, class, inalign ko sa left yung no? Let me just show that, no? So, tingnan nyo to, class, no? So, first, ito yung math. Okay, bold font yung Y. Kaya nga naka-bold yung class yung Y. Yan. Okay, mathematical, bold font yung Y, and then text. Pag text, class, yan, is the vector of responses. Dinalagay natin text. Okay, asan na siya? Ito. Ito naman yung math BF, a bold font, tapos X naman to. Tapos yung beta, bold symbol naman siya, no? Beta. All right, so just take a look at this, class, and take note of this, begin array. Okay, L means parang left aligned siya. Okay, kaya tingnan nyo, class. Ito, center aligned. Ito, left aligned. So this is quite an easy way to, ang hirap kasi, class, sa Excel, ang hirap nito. In R, you just have to know paano ba yung code nitong Y na to, math BF na to, math BF din. Okay, math symbol, bold symbol, etc. Okay. Then, as I said a while ago, class, let me share this with you. You'll use matrix multiplication, matrix operations in order to solve for your betas. Yung betas natin, class, yun yung mga unknowns natin, yun yung mga parameters natin. Diba? And that's our main object class for multiple linear regression. So from this equation here, we can show mathematically using linear algebra that beta, which is the vector of your parameters, this is what we're solving, is equal to X transpose X inverse X transpose Y. So this is the matrix multiplication of X transpose times X, and then get the inverse multiplied by X transpose times Y. Okay, so I just want you to remember this. Okay, did you discuss this class in FinMath? Nag-request ako sa FinMath kasi na sana i-discuss tong operations ng regression sa matrices. Did you discuss it, class? Chat yes or no, please. Kung itong formula na to, na-meet nyo na ba to? Ano, okay. Sige, okay lang. So, okay, just for the information of everyone, class, sabi natin, di ba, yung table natin kanina containing the vector of your dependent variable and the vector of your independent variables, including si beta null. Alinagay natin dun 1, ano? 1 lahat. Multiplied by the vector of your parameters, yung beta natin. This can be solved using, if we simplify that class using matrix algebra, then you have this. Okay? Notice this is hat, which means this is the computed value. Ginawa kong wide hat para mas malaki siya. Ang liit eh. There, plus. Yan nyo, ano? Linagyan ko lang ng wide, naging lumaki na yung, yung hat. No? Okay, and in econometrics or in ano ba? Econometrics, yung hat class signifies that this is your predicted value or your solved value. So this is the value of your beta null, beta 1 up to beta 7. Ito yung class. So, well, we don't have to manually compute for this. No? Sa R, ang dali-dali nito. So we're going to make use both of the LM function and also pakita natin para alam nyo rin, class, kasi importante din na na hindi tayo ignorant sa ganitong formulation. So this is good knowledge also. Since finance, class, is truly quantitative ang finance. So ito, class, yung beta. Okay, so yung beta ko dito. Where gawin ko rin wide to, class, no? Wide, gawin yung wide, class. Yeah, beta is the vector of estimated coefficients. Okay. X transpose is the transpose of the matrix of predictors. X transpose X inverse is the inverse of the product of the transpose of it. Okay. And then X transpose Y is the product of the transpose of X, which is the matrix of predictors, and the vector of the response Y. Okay, so I know this might be quite a mouthful, class, but don't worry, class. Just konting i-memorize na lang, no? Muna, no? And there are many standard references in the internet that can show you how this was computed. Gumamit to ng konting a little bit of calculus, no? A little bit of linear algebra, of course, and a little bit of calculus. So, please take my word for it that yung equation of y is equal to x beta plus epsilon, for us to solve beta there, using matrix algebra, it's equivalent to x transpose x, inverse x transpose times x, and then inverse niya, multiplied by x transpose times y. This will generate now the vector of the parameters, yung sinosolve natin. Okay? So ito yung gagawin natin, class. Kailangan malaman natin yung betas natin. That will be your first step, no? Ano yung value sa mga beta null natin hanggang beta 1, beta 2, etc. Then after that, class, mamaya lang, Juliana. Alam nyo, may nagtatanong kung mag-member kay class ng ng MAFIA, no? Yung incentive, kasi konti lang yun eh. Doon na lang natin i-incentivize yung mga class sa mga exams nyo. Mas malaking incentive ang binibigay ko kasi exams. So, you will not actually need the incentive to join MAFIA. I want you to join it because it has value for you. Hindi yung magkakaroon kayo ng points, no, class. Yun ang gusto kong maging rational nyo for joining kasi networking yan, tapos marami pang benefits na makukuha kayo. Kasi kung +1, +2 lang dito sa it doesn't really make a dent, no? So I hope class, I didn't want to dilute the relevance of joining MAFIA by some points dito sa subject na to. Wala yung class, no? Ang importante, yung bigger value sa inyo na pag-join ng MAFIA. That's what I want you to understand. Okay? Thank you, Juliana, for that, no? Okay, so, malaki class, no? Malaki yung benefits ng MAFIA, not only the points here in FINARTS. Okay? But I do give incentives here, and it will be much more than just giving points for joining MAFIA. So please join, no? Please join. All right, so ito class, no? So if I ask you, for example, although hindi naman kasama sa exam to, how do you compute for beta given this matrix formulation? Well, dapat i-memorize nyo, no? Beta is equal to x transpose times x, matrix multiply siya, inverse times x transpose y. Yung first three, panay x naman class, di ba? Yan. And then sa y. Notice class, ito yung mga givens, no? Okay, alam natin yung X matrix. Alam natin yung Y matrix. Kasi data yan eh, class, di ba? So we can perform this. Pwede natin siya ma-perform tong operation na yan. Okay, any questions so far, class? Pakichat nga please kung klaro yung discussion natin, yung equation natin, yung matrix equation natin, and then yung kung paano sinusolve si beta. Kindly chat please, class, if okay tayo so far, kung clear so far. Well, not yet the computation itself, no, but at least the equation. Okay, thank you. About the others, waiting for the others to give their feedback, please. Siya pa lang, nag-feedback. Yung iba, may questions ba? Okay. Okay, let's wait for the others. Need your feedback, class, kasi baka masyado akong mabilis o baka masyadong Greek yung yung hindi naintindihan yung sinasabi ko. Konti pa lang nagre-respond. Okay. A few more seconds, class. Gusto ko sana majority ng class nagre-respond. Okay. Okay, thank you. All right. So we have the equation. We have the matrix representation of our data. And then we have the solution for beta. Then we go to the assumptions class. Assumptions of classical multiple linear regression. So this one class, maraming references nito, no? So ang unang assumption, linearity. Okay, what do we mean by linearity? Dapat linear yung relationship ng x at saka ng y natin. Okay, linear dapat yung relationship ng x ng mga independent variable natin at saka dependent variable natin. So in other words, class, if we're going to plot, for example, so this is our y, no? This is your dependent variable and this is your one independent variable. If you plot them, the scatter plot should be more or less like this. Okay, so you can see that the scatter plot seems to point to a linear relationship between your dependent variable y and your independent variable x. That's what we mean, that's one of the meanings of linearity. May isa pang linearity na titingnan natin. Okay. Now, if in the case of a data that looks like this. This is your X, this is your Y, and your data looks like this. So parang ganito siya. Okay. So you notice that Y and X don't appear to be linear. They appear to be quadratic, no? Okay, parabolic siya, pointing upwards. So in this case, class, it might not be a good idea to use multiple linear. As the name suggests, class, linear dapat regression. Linear dapat yung relationship ng Y natin at saka ng X natin. So for variables, independent variables that relate to your dependent variable in this manner, then MLR, multiple linear regression, might not be the best. No? Malamang baka quadratic regression or polynomial regression ang maganda dito, class. No? So that's the first assumption, dapat linear yung relationships ng ano natin, ng dependent variable at saka ng independent variable. Okay, is that clear, class? Paki-chat please. If that first condition, class, is clear, yung linearity, assumption yan, class, ng multiple linear regression. Remember, class, that we said once we solve the model, we're going back to it. We're going back to it and check, class, if if we're able to meet the requirements. Okay, thank you. All ko muna. So the first assumption, dapat yung relationship ni IV natin at saka DV can be characterized by a straight line. Yun ang linear, class. The relationship between the predictors and the outcome variable is assumed to be linear. And as we showed a while ago, one way to check that is using scatter plots. Plot natin para makita natin kung linear sila. Okay? So wait lang. And let me share ko na lang din to, yung notes na to. Control C. Okay. All right. So that's what this paragraph means, class. Dapat linear yung relationship nila. Now, take a look at this, class. This is the equation. Okay. This is the equation for linearity. Your Y, this is your dependent variable, is equal to your intercept, class, plus the sum of your betas and your X. Notice your X, class, is linear. Hindi siya naka-squared, hindi siya naka-square root, hindi siya naka 1 over X. Okay? So linear siya dito, no? You can see here. Linear. X. Hindi siya squared. Hindi siya cube. Hindi siya square root. Hindi siya 1 over X. Okay? Linear ang relationships ng Y at saka ng X. Okay, take a look at this, class, no? How did I write this sigma sign here? Okay, ito lang siya. By the way, quad here, class, means quad, yung parang double space siya. Okay, just to illustrate, class, para medyo alam nyo rin, kasi pwedeng, ano yan, pwedeng, yung space niya, class, pwedeng ganito, no? I'll replace quad with semicolon. Tingnan nyo, class, no? Nagbago yung space dito. Comma. Sorry, comma pala. Comma, lumiit, no? Comma, pinakamaliit. Tapos semicolon, mas malaki ng konti. Semicolon. And then, colon, yung mas malaki, no? And then, yung quad, it means put a space. Okay. Linearity and then space, no? So, gusto ko lang lagyan ng space between linearity and y sub I. Actually, meron pa mas malaki, yung Q quad. No? Q quad. Ayan, tinan nyo. Parang double siya ng quad. Okay, anyway, para naintindihan nyo lang, class, no? As we go along, I'm explaining to you how I did the LaTeX, no? All right? And then here, class, ito, yung summation sum. Sum, okay, underscore, then ito yung lower limit natin, j is equal to 1, caret p. Okay, pwede ko rin ilagay dito, open J is equal to P. Yan, tinan nyo class, no? From J is equal to 1 up to J is equal to P. Ito yan. Sum underscore and then yun. Okay? Actually, madali lang siya class, no? It's, of course, it's a matter of familiarization. And then ito yung beta underscore sa J, X underscore JI, yan, plus underscore, slash epsilon underscore I. Okay, so simula class, of course, may learning curve, but once you i-review, tinan nyo kung paano ginagawa, then I'm pretty sure in no time at all, makukuha nyo na yan. Okay? Note, meron tayong tinatawag na linearity between Y and X. Meron ding linearity of the parameters. Okay, so this is a related assumption. Okay, so share ko na lang to. Okay, here, Control C. What do we mean by linearity of the assumptions? Of the, okay, linearity of the parameters. Control V. Okay, tingnan natin class. Linearity of the, nagkamali yata ang sulat, no? And linearity of the parameters class. So what do we mean by this? Okay, so naka-explain dito. Yung betas natin class, dapat linear din siya. Take a look at this. So ito class, hindi pa pwede ito. The betas, the parameters, could not be non-linear. So beta squared, hindi pa pwede yan. Square root of beta, hindi pa pwede. 1 over beta, hindi pa pwede class. Okay? So that's a very important assumption also. Hindi lang linearity of the parameters form multilinear regression. So ito, beta squared, okay? And then dito kunyari, square root of beta. O ito, 1 over beta. Okay? Why are these not allowed? Kasi mahihirapan class, isolve yung beta niyan. Okay? Magiging complicated yung pag-solve ng beta. Okay, that's why there's a strict requirement na dapat linear in the parameters. So yung kanina natin, beta 1, beta 2, beta 3, okay yon, kasi linear in parameters yon. Hindi pa pwede naka-beta squared, square root of beta, 1 over beta. Okay? Once again, class, again, sorry for asking again questions. Clear ba to, class? Clear? Magaling ko lang itong clear. Okay, clear class? Paki-chat naman please kung clear yung sinasabi natin, linearity not only in the relationship between X and Y, but also linearity in the parameters. Okay. Okay, class, ano please? Comment? Okay, good. Good. All right. Another, okay, this is assumption number 2 actually, no? Independence. Okay, ano ibig sabihin ng independence class? So this has now something to do with the residuals. Okay, so let me share this with you so that you can, hindi nyo na isusulat yung LaTeX. By the way, class, ang spelling ng LaTeX, L-A-T-E-X, no? Pero you pronounce it as LaTeX. All right, so what does this mean? Observations are independent of each other, okay? But more so, the independence here are actually about the residuals. There should be no autocorrelation among the residuals. We'll discuss residuals as we go along. Suffice it to say now, class, that dapat yung mga residuals natin, hindi sila correlated. No? Dapat independent sila. And how do you express that? Ito yung mathematical expression ng independence. The covariance, which is also related to correlation. Ano bang difference class ng covariance at saka correlation? Sige nga. Anyone class? Stock knowledge, ano difference ng covariance at correlation? Correlation is simply blank na covariance. Anyone? Covariance and correlation are correlated, no? Covariance and correlation are related sila. I'm sorry, I should use the same word. So si covariance at saka si correlation, actually pareho lang yan. Correlation, ano yung values ni correlation class? It ranges from, paki-chat please. Correlation, ano yung range ng values ni ano ni correlation class? Ranges from what? Correct. Thank you, Simon. Audrey, thank you. So it's negative 1 to 1. Si covariance sound, wala. Okay? Pero class, may formula yan. Si correlation is simply equal to the covariance divided by the standard deviation ng mga parameters natin. So si correlation is actually normalized, no, na covariance. But they mean the same thing. Okay? Pag yung negative yung correlation, negative din yung covariance. Pareho din interpretation nila. So ang sinasabi dito class, covariance ni epsilon sub I, yung residual ni observation I, and then the residual ng ni observation J should be equal to 0. Ibig sabihin wala silang correlation. For all I is not equal to J. Okay? Ang ibig sabihin to class, for all I not equal to J. Kasi syempre, pag I is equal to J, edi magiging 1 na yon. Kasi what's the correlation between epsilon sub I and epsilon sub I? Diba? Correlation of 1 with itself. Then that will be equal to 1. Yun ang ibig sabihin nito class. Ha? Okay? So ito class, itong symbol na to, yung for all yan. Yan. For all. Yan. I'm sure hindi nyo na panamimik yan class. Hindi naman kayong math majors. Pero importante sa atin class na nasusulat natin yan. Kasi who knows, sa paper nyo, sa thesis nyo, baka kailangan nyo isulat yung gantong terminologies. At least alam nyo. No? And you know the quad already. So independent class. Now, itong independence na ano na to, na assumption, this is not so much for data, for multiple linear regression that are ano class? Cross-sectional. Cross-sectional. Okay? So which means, discussan din natin, ano yung tatlong klase ng data class? Generally, meron tayong tatlong klaseng data. You have cross-sectional, we have time series, and you have panel data. Ano yung difference ng tatlong yan, class? Panel data. What's the difference? Tingnan natin in terms of point in time, yung time frame, at saka tingnan natin yung in terms of units. Okay, so let me explain. Ang cross-sectional data class, you're taking a look at it at one point in time. And you have many units. Okay, tingnan natin wage data set natin, no? Cross-sectional yan, no? Kasi, one point in time kinuha yan, 1970 yata, if I'm not mistaken. Tapos there are several units. Yung units din yung mga individual responses. Okay, so that's a cross-sectional data. On the other hand, ang time series class, okay, many points in time, several points in time. At saka, unit, one unit. So nagbaliktad sila ni cross-sectional. Example class. Okay, cross-sectional ulit, example. You're looking at the GDP, GNP, money supply, employment rate, birth rate, etc. of several countries. ASEAN na lang, ASEAN. In 2023. Okay? Cross-sectional ba yun? Yes, class. Kasi ang point in time natin, isa lang, 2023. Ano yung mga units natin? Yung ASEAN countries. Okay? So you have several countries, pero ang tinitingnan lang natin one point in time. On the other hand, pag time series class, baliktad. You have many points in time. Let's say from 1970 to 2023. Okay? So lahat ng GDP, GNP, money supply, unemployment rate, birth rate, death rate, etc. Okay, we're taking a look at it at those variables from 1970, 71, 72, 73, etc. Okay, pero ang tinitingnan natin, one, si Philippines lang. Okay, so in that case, that's a time series data. Okay, and then lastly, panel data class. Panel data is a combination of cross-sectional and time. So many points in time and many observations. Yun ang panel data, which is the most robust of these three. So based on the example, 1970 to 2023. Ano yung mga units natin? Singapore, Philippines, Malaysia, Thailand, Indonesia, etc., Vietnam. Okay? Lahat ng mga yun. Okay, and then meron tayong tinatawag na balance at saka unbalanced. Balance class from 1970 hanggang 2023, pareho lahat ng mga countries ng ASEAN ando doon, kompleto sila. Unbalanced, pwedeng no 1970, 2 countries pa lang. Tapos later on naging 3 na. Tapos later on naging 5 na. Tapos may natatanggal din across the years. So that's what we call an unbalanced panel data. Pag balance, from 1970 hanggang 2023, kompleto yung ASEAN 5 kunyari. No? Alright? So, pause muna ako class. Clear ba yung class? Yung pag-discuss natin ng time cross-sectional, time series, at saka ng panel data. Clear? About the others,
Sir,
please?
question
Yes?
po.
Yes, question. Yes, go ahead.
If balanced data po, there is no missing observation lang. Pag
Yeah.
unbalanced po, may missing lang po.
Not necessarily missing naman. Ang pag sinabing unbalanced, may mga ibang countries or may mga ibang units, depende sa case, no, na pumapasok siya in some points in time, tapos pwede siyang mawala, no? So kunyari, ang data natin 1970 to 2023. Nagsimula muna tayo sa yung mafilindo muna. 1970s, mafilindo muna yan eh. Malaysia, Philippines, Indonesia. Tapos across time, nadagdagan ng iba. Ba? Across time, nadagdagan pa ng iba, no? So that is a case of panel data. To say that it's missing, well, loosely speaking, yes. Kasi missing, wala siya noong 1970, no? Okay? Kasi pag missing minsan, ang technicality niyan, may data pero hindi na nalagay doon. Yun ang sinasabi natin missing data in our case. Okay, but thank you. That's a very good question. Okay? Did that answer your question? Sino nagtanong?
Yes po, sir. Clear
Okay.
po.
Okay, good. Thank you. Thank you. All right, sige. Good. Bring in your questions, class. Huh? Okay, next. Ito naman. Ito, homoscedasticity. Take note, class. Number 3 na pala to. As I'm discussing this, dinidiscuss ko na rin yung equation para familiar tayo. No? Control C, may konting minutes pa tayo. Control V, sana matapos lang natin yung Control V. Okay, there you go. And then pakiran class yung homoscedasticity. There. Okay. Ano naman yung homoscedasticity class? Assumption ng model natin to, no? Dapat yung variance ng residuals natin should be constant for all i's. Okay? The variance of your residuals. Take note, it's variance only class. Kasi you're just taking a look at one variable. Covariance to, kung 2 variables yung tinitingnan natin, is equal to constant. Now, let me quickly illustrate that. Almost time, class, but I hope if you need to go, class, I hope you'll allow me just to discuss the last, no? Yung huling-huli lang. At saka yung, para ma-describe ko. Para tapos na yung, yung assumptions na yan. Okay? Annotate. I'll need mga 2 to 3 minutes more. So ito, class, no? So let's say this is the value of your predicted value or any of your independent variable, and this is your residual. Yung residual class, we'll discuss this in greater detail next time. Pero yung residual is the difference between your actual value and your predicted value. Kasi di ba may model tayo. Yung model natin, ando dun yung mga betas natin. So kapag sinubstitute natin yung mga actual values to the equation, you'll have your predicted value. And then the actual value minus your predicted value is your residual. Now, dapat class, yung plot ng residuals compared to, let's say, X class, dapat constant yan. Dapat ganito yan, class. Ganito dapat yung plot niyan. Dapat hindi siya tumataas, wala siyang trend. Okay? Or dapat yung variance siya, hindi nag-i-increase. Ano ibig sabihin ng may trend? Pag yung residuals mo, no, class, ang plot ng nakaganyan, may trend yun, Heteroscedastic yan. Hindi pa pwede ang class. Pag prinat natin residuals. Kasi may pattern pa yan eh. It means that your model was not able to capture this behavior of your data. Also, hindi pa pwede yung ito kasi class, di ba? In a sense, non-constant variance yan. May trend yung residuals natin. Also, yung residuals natin, dapat constant. How does that look like? Okay, hindi pa pwede yung residuals natin ganyan. Ano yung class? Gumagano yung residuals natin. Okay, may fanning out class or fanning in. Fanning in, fan. Parang fan class, yung paypay, no? Fanning in, papasok. Fanning out, palabas. So yung residuals natin class, hindi siya constant kasi across higher values of x, malaki yung mga residuals mo, no? Dito, malalaki siya. So lumalaki class yung variance. So hindi constant variance yan class. So this is a phenomenon called heteroscedasticity. Okay? And we don't want the model to be heteroscedastic. We don't want the residuals to be heteroscedastic kasi that will violate the assumptions. Okay? The assumptions of classical linear regression model. Ito yan, class. And lastly, class, ito na lang, share ko na lang to. Control C, Control V, and isa pa, para tapos ko na ma-share to. Normality na lang. Control C. Okay, yung dalawang assumptions na to. Number one, class, is okay, no multicollinearity. When we say no multicollinearity, class, we're taking a look at the relationship between your variables, your independent variables. Hindi pa pwede, class, na highly correlated yung mga independent variables nyo. Gusto natin, class, let me illustrate that quickly. We want that your y, your dependent variable, and your independent variable are highly correlated. Gusto natin yung ganyan. Gusto natin highly correlated, whether up or down. But we don't want your x and your x. Ayaw natin na highly correlated siya, class. May ganyan siya. Mataas yung correlation. We don't want that. And we call that multicollinearity. Why do we not want that? Kasi, class, we will find it difficult, okay, to disentangle yung effect nila kay y. Kasi they're behaving similarly, no? Highly correlated sila. It means that they might be explaining the same thing about y. Okay, so we don't want this. We don't want the independent variables to be highly correlated. We don't want them to be correlated. Okay, we want the dependent variable to be correlated with your independent variable. Yun ang gusto natin. But not the dependent variables correlated with each other. Okay, so that's what we mean by no multicollinearity. And we actually measure that, class. Later on, we'll learn that how do we determine kung may multicollinearity siya. Okay, ito yung class. There's a factor called VIF, the variance inflation factor. We're going to measure this next meeting, no? Para malaman natin kung may multicollinearity. And lastly, class, residuals data, which I mentioned a while ago kanina, no? The residual should be distributed. Dapat ang behavior niya normal siya, no? Normal distributed with zero mean and a constant standard deviation. Okay? All right. So with that, class, okay, isama ko na lang tong notes na to para nabigay ko na to. This one, references. Control C, Control V. Okay?